This is the 7th video presentation for the CASE Plant course. As you view this video, make note of important information. Pause, repeat, and resume the video whenever necessary. A Dash of Salinity, Lesson 2.2, Soil Chemistry. You just completed Activity 2.2.2, Correction of a pH Problem. In addition to pH, another major soil chemistry problem is salinity. A saline soil is a soil containing soluble salts in such quantities that they interfere with the growth of most crop plants. The type of salt depends on the management practices, such as the type of fertilizer used. The greatest contributing factor of salt for farmland is the parent material of the region. How does your local parent material affect salinity? Think of very dry, hot areas with a lot of evaporation. These soils are sometimes very poorly defined with hard pans or fine textures that prevent drainage. As solutions are added to the soil, the water will either evaporate or percolate, leaving the salts to accumulate on the surface. Bottom watering systems are methods still used in some commercial operations. Essentially, the greenhouse table is a large but shallow bathtub. The water is flooded in the table and the soil soaks water in through the drainage holes of the pots. Usually, fertilizer is added to the water. The upward force of the water soaking into the pots keeps accumulating salts toward the upper portion of the container and never flushes or leaches the salts away. With a good overhead watering system, salts are continually flushed through the pots. As a result, you will find fine, white crushed crystals around the drain holes of many hanging pots. Some plants grow very well in high salinity soil. One example is grass found on a saltwater beach. Other plants have developed a tolerance to higher levels of salts, but still grow better in optimal salinity levels. If a plant is suffering from salinity overdose, it will wilt and show signs of a nutrient deficiency. Amending saline soils is usually not economical for raising crops. These soils are typically used for grazing or other purposes rather than intensive crop production. With water becoming a scarce resource in arid regions, reclaiming saline or sodic soils is not feasible. Prevention is the best measure to avoid salinity-related problems. You will need to monitor potting soil closely if you suspect a salinity problem. During Activity 2.2.3, Salty Soil, you will measure electrical conductivity of soil using laboratory equipment you have available. In industry, you would use more specialized equipment to detect the presence of specific salts. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 2.2.3 Salty Soil, you will determine the salinity of soil by measuring the electrical conductivity to determine the effects of chemical fertilizers on soil salinity levels. This will help you understand that soil salinity concentration determines how well plants uptake water, and as a result, the ability of plants to absorb the available necessary nutrients. Your instructor will share where to gather the soil samples and materials needed for this activity. During this lab, you'll be using the Vernier LabQuest 2 and conductivity sensor. The next clip in the video will show you how to correctly operate this equipment.
This is the conductivity sensor. What it does is it's measuring the conductivity in the solution. Place your probe down into the liquid deep enough that you're actually covering the lower part here where the sensor is. This is a multi-range sensor. It has a switch here on the end, and this allows you to adjust it for what you expect your values to be. And so it's a sensitivity switch. So let's collect some data. I'm ready to attach my sensor to the LabQuest. So I'm going to plug it in here. And when I do this, it's going to default to finding the sensor there. And we see our meter screen here, and it's giving me a reading there close to 0 for my distilled water, so that's nice. The collection parameters up here in the upper right corner are time-based, meaning that we're looking at conductivity as a function of time. The rate is 1 sample per second as the default. for 3 minutes or 180 seconds. So I'm ready to begin collection, so I'm going to press the start button down here and let it start collection. After we hit stop, the graph auto-scales, and it's making it as large as possible given the day we've collected. So again, this is the vernier conductivity probe. It's used widely across a lot of our different labs.